Jai Hind, my name is Pardeep and I am working as an assistant professor in IT department in Ajay Kumar Garg Engineering College, Ghaziabad. Today we will discuss the subject theory of automata and formal language. Okay, the subject code is KCS 402. KCS 402. Okay. So in the previous lecture series we have discussed DFAs, okay, and we have constructed some DFA. In this lecture also we construct some more type of DFAs, okay. So before that I again revise the 5 quintuple of DFA. The DFA is defined by quintuple Q sigma delta Q node and F, where Q is the finite and non-empty set of internal state, sigma is the input alphabet, it is the finite and non-empty set of input symbol, delta is the transition function, Q node is the initial state, F is the final set, okay, which is the non-empty and finite, okay. So let's construct some type of DFAs, okay. Now let's see the first question, that construct the DFA over sigma equal to 0, 1, okay, okay, it will be A, B, okay. By mistake it will be A, B, which accept set of all string which start with A and end with B, set of all string which start with A and end with B. So here sigma equal to A, B, okay, and what is the language? Language will be containing the set of all string which start with A and end with B. So only AB start with A, end with B. A, B, this also start with A, end with B. A, B, B, this string start with A and end with B. Now A, B, this string also start with A, end with B, and so okay, there are infinite number of strings over A, B that start with A and end with B. So let's construct the DFA corresponding to that language. Suppose there is state Q node, initial state that start with A, okay, on input A, that goes to suppose Q1, and Q1 on input B goes to QF. This is the NFA which accept the string which start with A and end with B. Why NFA? Why not DFA? Because here for input B transition is not defined, at Q1 also for input A transition is not defined, and at QF also for input A and B transition is not defined, okay. So let's change the color. So it will not accept the string which start with B, okay. So what will happen with string start with B? It will goes to the dead state, it will goes to the dead state, okay, or you can say trap state, and on dead state on input A and B it still remains in dead state, okay. Now start with A, end with B. If I put a loop here, A and a number of A. Okay, it start with A, this thing is correct. Now still it is ending with B, so there is no effect. So at Q node A and B is defined, at Q1 A and B is defined. Now at QF A and B is not defined. Okay, start with A and with B. So if I make a loop here for input B, still this does not violate the condition. It start with A and end with B. Now on input A, just move backward. Okay, so now it start with A and end with B. Now just make a transition in backward direction for input A on QF. So it start with A, end with B. On upon A, it moves to backward and again end with B. So there is one thing to note here. I never move this transition, this A move to Q node. Why? Because suppose there is input A, B, A and B. If I make this transition instead of this transition, okay, if I make this transition A, B, A, B, so according to this language this string will be accepted. If I make this transition from QF to Q node, so I am at state Q node on input A, goes to Q1, Q1 on input B goes to QF, QF on input A goes to Q node. If I make this transition instead of this green color transition, if I make this red color transition, QF to Q node, it goes to Q node and Q node on B goes to dead state. So this will be wrong. Okay, still although this string is present in the language, but if I make this transition, then this will not accept this string. Okay, so that's why I make this transition QF to Q1 only, not Q node. Okay, so just remove this transition. Okay, so this is the final DFA. This is the final DFA for the language which accepts set of all string which start with A and end with B. Now see the next example. Okay, construct the DFA over sigma equal to, okay, just write A comma B instead of 0 1, just write it as A comma B okay, A comma B which accepts set of all string which start and end with different symbols. This is very important, start and end with different symbol. Suppose a language which start with A, that must be end with B, and a language which start with B must be end with A. Okay, so these type of string must be accepted by the DFA. That will be the required DFA that we need to construct here. So here sigma equal to A comma B, okay, and the required language will be which start and end with different symbol. So A and B is one of the string. Start with A and with B. Start with B and with A. Start with A and with B. Start with B and with A. B, B, A, B, A, A, B, A, B, and so on. So these are the sample string that will be accepted by the finite automata, and this string must be present in the language. So you just need to construct the DFA. So construct the DFA Q node, start and end with different symbols. Okay, so it start with A, goes to Q1, and with B. Okay, this start with A and with B. So it start with A and with B means these start and end symbols are different. Similarly, if it start with B, Q2, this is final state 1, there will be more than one final state, and with A, final state 2. Okay, this start with B and with A. Fine. Now this is not DFA, this is an NFA. This is an NFA. So at Q node A and B is defined. At Q1 only B is defined, A is not defined. If I make a transition A, now start with A, n number of A, and end with B, so there will be no effect. So at Q node and Q1 transition is defined. Now what about QF? I make a transition of B on QF itself. Okay, now start with A and with B. Now upon A it goes to Q1. It goes to Q1. Okay, so this is the set of all string that start with A and with B. Similarly, here just write a loop for B and backward transition. B, start with B and with A, and here loop of A. So this part is set of all string that start with A and with B. This part is set of all string that start with B and with A, and combinedly this makes the DFA that start and ends with different symbol. So this is the required DFA. Okay, this is the required DFA. Okay, right. Next, see, construct the DFA over sigma equal to A comma B over sigma equal to A comma B, which accepts set of all string which start and end with same symbol. Which start and end with same symbol. Okay. So what it means, if a string start with A, it must end with A. If a string start with B, it must end with B. Okay, so the sigma equal to A comma B. Okay, and the language will be A, because A start with A and with B. B also start with B and with B. Epsilon also, epsilon start with epsilon, ends with epsilon, and A, B, B, A, B, A, A B B A B A A B B. So all these strings comes under these categories. That all these strings start with and end with same symbol, B B A A B B and so on. Okay. So basically this language is the complement of the previous language. This language is the complement of the previous language. Okay. So it is easy to write, to construct a DFA that start and end with different symbol, then we convert into with the same symbol. Okay. Q0 on input A, Q1 B. First I make the DFA that start and end with different symbol, B, Q2 A, QF2. Okay, this is the final state. Now n number of B here, this backward transition, n number of A here, n number of B here, and this backward transition. This is the DFA which starts and end with different symbols. Okay. So if I take the complement of the previous language, okay, so language 1 is start and end with different symbol, start and end with different symbol, and L1 language complement will be start and end with same symbol. So how we take the complement of this DFA? Just make the final state to non-final state and make the non-final state to final state, and make the non-final state to final state, non-final state to final state. So how we can do that? So make the non-final state to final state. So this state will also be final state, this state will also be final state because these are non-final. This state will also be the final state, and the final state will be the non-final state. So this will be the non-final state. So this is the required DFA which start and end with same symbol. So it start with A, end with A. Okay. If there is B, it goes to QF, again A, end with A. Start with A, end with A. Start with B, end with B itself. Okay. So this is the required DFA. Now construct the DFA over sigma equal to A comma B such that number of A, N stands for number of A in string mod 2 equal to 0 and number of B in string mod 2 equal to 0. Okay. So there are how many state total? So this mod shows how many state? 2 and 2. This and is here, 2 and 2. So totally there are 4 state. So we construct the 4 state here. Okay, suppose this is the initial state. Q0, Q1, Q2 and Q3. Okay. So here mod 2 means even number of A and mod 2 means even number of B. So suppose here epsilon means 0, so even, okay, even number of state, or you can say 0 number of A and 0 number of B. Here if 0 number of A, 1 number of B means even, odd. Here odd, even if 1 number of A and 0 number of B. So AB here, AB, odd, 1 number of A, 1 number of B, A, B. Okay, so this will be the final state. Okay, 0 number of, 0 number of B. Now see 0 number of A, so this transition will be B. Parallel to this, write the same transition B, and to this transition A. Okay, here 0 number of A, 0 number of B. Here 1 number of A, 0 number of B. Here 1 number of A, B, 1, 1. Here 0 number of A, 0 number of 1 number of B. Okay, so this is the final DFA for the given language. So this way we construct the DFA. Fine. Next is the next DFA construction, that number of A mod 3 equal to number of B mod 2 equal to 0. So what it means? So there are totally 3 into 2, 6 state. So 6 state will be there. 1, 2, 3, 4, 5, 6. 6 state will be there. So when we divide by 3, then the remainder will be either 0, 1 and 2. So suppose this is the initial state. So remainder will be 0, 1 and 2. Remainder will be 0, 1 and 2 for the number of A. For B, remainder will be 0 and 1. So it will be 0 and 1. It will be 0 and 1. 0 and 1. Okay. So these 6 states are there. Okay. So here it will choose A. Remainder A, 1, 2, 0, 1, 2. So just try the transition A and A. Means 0A, 1A, 2A and again 3A. 3 mod 3 again 0A. Similarly A and make the transition A here. Now 0B means here 1B, again 2B, 2 mod 2 equal to 0. Similarly same transition we write here and same transition we write here. So this is the final DFA for this language. Okay, thank you.